All right, and it is time for chapter 1 with your teacher, that's me, Mr. Hain. All right, here we go. So let's do a quick review of how we make fractions into decimals. And of course, that relates to our essential question, which does go in your notes. How are fractions and decimal numbers equivalent? Equivalent. It sounds like the word equal. So really, we're looking at how to make different expressions of the same number equal. Essential question. All right. So this should come as a straight review, but let's just change this fraction into a decimal. If you recall, the top number is inside and the bottom number is outside. Here we go. That's what it looks like when we are doing long division. Now, 5 cannot go into 2. So I'm going to walk through this example. And more important than writing just the answer down is showing all of your work, even if you already can do it in your head or have memorized this fraction. It does not matter. Okay, so I know that 5, add the decimal on top, and 5 does not go into 2, but it does. 4 times 5 is 20, and that does equal 0, which means that my decimal equivalent of 2/5 is 4/10, or 0.4. Excellent. So, if this is your first video that you're watching from me, feel free to pause at any time. I don't get offended because I'm being recorded. It's my regular recorded voice. So, the other thing is, all of the rest of these, or some of the rest of these, I do not show the work on. And that's because you need to show the work, especially if you're in my classroom or taking math from me, Mr. Hain. You're going to have to show that work because that's what's graded. I do not grade the answers. I grade the work so I can see if you're understanding how to get those answers. All right, let's dive back in. For 7/8, you remember what's in, you remember what's out. If you said the 7 is in, that is right. In fact, I'd encourage you right now to pause the video and try to work this problem out on your own. I'll be right back. Gotcha. I'm back. And if you actually did the work here and showed that it is equal to 0.875 or 875 thousandths, then you are absolutely correct. Remember, it's the work that's important. So I'm not showing it on the screen. You need to have it in your notes. And of course, 7/8 is equal to 0.875 or 875 thousandths. Excellent. All right, moving on. We've got an unusual example. And see, the thing is, when I start doing this, I know that I get a repeating number. Like, I'm always going to multiply times 1. 1 times 9 is 9. And I'm always going to get 10 because I have an infinite number of zeros. What this means, what does it mean? If I always have the same number repeating over and over again, there's a symbol that we can use to show that it's repeating. And in fact, that symbol is a bar over the ones. Now, I do not have to have the bar over both. In fact, because there's only one number that's repeating, I could write my answer as 0.1 with a bar on top of that, because that's the only digit that's repeating. So this is kind of like a check in your notes. If you have a 0.11 with a bar over the top of it, you're not listening. But if you do have 0.1 with a bar over it, showing that is 1 repeating, then you are listening. That is the correct notes. Thank you very much. So let's take a look. I would encourage you to pause this video and try this. Use a calculator if you want to. Google it. Yes, I'd even said that. And see what you get. And we're back. Did you get like 35 repeating? This seems to mean something because I feel like we're having a pattern here. Like if I just have 1 9 at the bottom and 1 2, did you say 0.2 repeating? That's what I thought. But if I have like 57 over 99 and there's 2 9s on the bottom and 2 9s on the top, or 2 numbers on the top, yeah, you should get this one on your own. And of course, we can work backwards and we can make this 0.45 repeating. We know this 4 5, 2 digits, 2 9s. Yep, you should have a fraction. Now, remember, if you're in my classroom, I'm probably having students work this out. But if you're at home, you need to work it out on your own, using my examples in previous slides as a way to work this. And as a hint, H and G are definitely connected, but I do have a 3 in the front of my decimal. This means 3 wholes. So I have 3 and 45 over 99, or 5/11ths. Part of this answer should probably look like part of that answer. Excellent. All right, well, make sure that you understand in this quick review about how to see the relationship between fractions and decimals. Sorry to sound like our 44th president, Barack Obama, there for a second. A rule for repeating decimals. Is there a rule for fractions with 9 as a denominator? You should write that in your notes. Go ahead and see the other examples that we did before if you're having trouble with that. Is there a rule for writing fractions that are equal to repeating decimal numbers? Kind of like what I had here in G. Is there a rule? What does it look like? Okay, write that rule in your notes. I am not writing it on this video, and I'm not writing it on the board probably. We might discuss it in class. And make sure that your summary is written. Make sure you've answered the essential question. Make sure that your table of contents is updated. And absolutely, absolutely take a look at this video to review before the test, before a quiz. Also, make sure to update your notes each time as you're reviewing with things that you might have missed the first time. And feel free to rewind the video and check out parts that you might not have understood the first go around and just look at it again. And until next time, students, keep on doing the math.